Alright, so this time I will be solving WebAssign activity 1.2, which is limits, properties algebraically. Is this one here. In this case, I just printed it out so I can write over the page, but you will see it like this in WebAssign. That's why it looks slightly different, just because I printed out into a file, but it's essentially the same activity. For this one, you have to use remember the properties of limits that we learned this week. For example, when you have limit of the sum of two functions f and g as they approach a number a, well, you can split that into two different limits that are added up. Alright, that's one of the properties. There is this other property that is for the product of limits. For example, f of x times g of x as x approaches a. For that one, you take the limit of the first one and then you multiply it by the limit of the second one. Okay, essentially the same. These and other properties that we saw during the week. Alright, and exactly that is what we are being asked in the first question. Suppose the following limits exist. The limit of f of x as x approaches a, and the limit of g of x as x approaches a. Then, what will happen to the limit as x approaches a of the sum of these two functions? Well, what will happen is here that I can also solve it as the limit of the first one plus the limit of the second one individually. Okay. Please make sure that this is the right answer, not this one, because here there is an x and here there is an a. Okay, that is tricky, and that is just a property. And here for the second one, I have the product of those two functions, and I want to find the limit as x approaches a. For this one, it's the same. I can also just take the limit of the first one and then multiply it by the limit of the second one. And these are the first properties of limits. Okay. Now, here I have the graphs of f and g are given. Use them to evaluate each limit if it exists. If an answer does not exist, enter D and E. So here I have these two graphs, and I am being asked to find some limits. The first limit here, a. This one is telling me what is the limit of the sum of these two functions when x approaches 2. Okay, so I have the graph of f of x and I have the graph of g of x, but I don't have the graph of f of x plus g of x, like, yeah, I don't have this graph. So if I want to find that limit, initially I don't have a way to do it because I don't know how that looks. So because I don't know how that looks, I need to find another way to solve these limits. So what I actually know from the previous properties we did is that I can rewrite this limit differently. Okay, and I can rewrite that as the limit of the first one as x approaches 2 plus the limit of the second one as x approaches 2. You see? Why is this useful? Because if I find each limit individually, I can actually do it with these graphs. Okay? If I first only the limit here, I have the graph for it. Or if I want to find a limit here, I also have the graph for it. So that's why I'm using that first property, okay, to be able to find each limit. And then after finding each limit, I will just add them up. the first limit, the limit of my function f of x here, when x approaches 2. Okay, here's my x-axis. Here's the number 0, here's the number 1, and here's the number 2. Please note what will happen to my y coordinate as I am approaching number 2, either from the left or from the right. From the left, I go like this, I approach this number, and from the right, I go like this, and I approach this number. What is this number in y? It is 2. So it doesn't matter if I'm approaching from the left or from the right. My limit as I approach 2 here is 2. Okay. Now, I am asked, what is the limit when my second function, g of x, as I approach the number 2 again? So here's 0, here's 1, and here's 2. From the left I go here, from the right I go here. They are the same, so the limit exists. And what is this number in y? In y the coordinate is 0, 0. Okay, so what is 2 plus 0? That is 2. Here, right, 2. Okay, easy one. For the number v, I will actually take the same approach because I am given the same functions and I know that I don't have a graph of f of x plus g of x. So I will again rewrite that as the limit of the first one plus the limit of the second one when x approaches 1, like that. Okay. Yeah, and then I only have to find this limit graphically in each graph. So for this first one, I am finding the limit as x approaches 1. Here's the number 1. You see, when I approach from the left or from the right, I get to the same point, so the limit exists. What is this point in y? Number 1. So here's the number 1. And what about the second limit? In the second graph, I am approaching 1. Here's 1. But look carefully here. Remember that if you want to find a limit, you have to make sure that both limits from left and right are the same. What happens when I approach x from the left? When I approach from the left, I come here, and I approach this number here. But when I am approaching from the right, here, I'm approaching that other number. You see, I am not getting to the same point. So it means that this limit is not defined. It does not exist. So this operation cannot be found. All right? Okay. For the third one, I have the limit of the product of these two functions. Just like for the first two exercises, I don't have a graph. For this function, f of x times g of x. I don't know how that looks, so I cannot find that limit just like that. I need to do properties, and the property that I am doing is taking each limit individually and then multiply them like this. As x approaches 0, as x approaches 0. You see? And that I can do it. I can take the first limit from the first graph and I can take the second limit from the second graph. Okay? So I will take the first one. What happens in my graph as I approach 0? I can do that. I have to do that from both sides, right? From the left, from the right, I get to the same point. So the limit exists. In this case, the limit is 0. Okay? What about the second limit? The second limit is the same as I approach 0, but in the second graph. From the left side, I go and I fall into this point. From the right side, I go like this, then I jump here, and I end up in the same point. So this limit exists. It does exist, but I actually don't care about the value. Like it could be 2 or 1 point something, but it doesn't matter. All I care about this one is to verify that this limit exists. Once I know that this limit exists, this is 0, because any number multiplied by 0 is 0. So this value is actually irrelevant. So here the limit is 0. Yeah, and actually if you take a look at the graph, it's actually very hard to tell what is that value. Like here, is it 1.3? Is it 1.5? It's hard to tell. It's hard to tell because it doesn't matter, because any number multiplied by 0 is 0. Alright, now I have another limit, and I would use just the same. I will take a property which tells me that I can take the limit of the first function over the limit of the second one, and don't forget to write as x approaches -1, as x approaches -1. So what happens first? In my first function, when I approach -1, here is 0, here is -1, here. From the left, I get here, from the right, I get here. It's the same point, so the limit exists. What is my y coordinate? -1. And now, for my second graph, when I approach -1 here, from the left, from the right, it does exist. Okay,